Consider the number 4 raised to n, where n is a natural number. Check whether there is any value of n for which 4 raised to n ends with the digit 0. So what we are going to use here is the fundamental theorem of arithmetic. That is, we are going to use fundamental theorem of arithmetic to show that, or to investigate that, whether the 4 raised to n ends with the digit 0. Okay. So for that, to prove last digit of 4 raised to n is 0 for some n, that is our problem. Okay. To prove or to check. For that, check the prime factorization of 4 raised to n. At first, we have to check the prime factorization of 4 raised to n. Since 4 raised to n is a composite number, we can express it in product of primes by the fundamental theorem of arithmetic. Here we are using our theorem. That is, we have an expression that says 4 raised to n. N can be any natural number. That is 4 square, 4 cube, 4 raised to 100, 4 raised to 1000, 4 raised to pro, 4 raised to something like that. Then we have to check whether for any end 4 raised to n ends with the digit 0. Okay, you know something, which numbers have an ending with 0. That is, that numbers are factors of 10. Okay, that is 10, 20, 30, 40, 100. Every number is a factor of 10. Okay, or a multiple of 10, then it will ends with the digit 0. Otherwise, that number doesn't end with the digit 0. So, to check whether 4 raised to n ends with 0, we have to get 4 raised to n is a factor of 10 here. So for that, at first check what is the prime factorization of 4 raised to n. Then you know that 4 equal to 2 into 2. Okay. That is 4 raised to n equal to 2 square into n, which is equal to 2 into 2 raised to n. That is a raised to b whole raised to c is a raised to bc. That is a raised to n whole raised to n is a raised to mn. By using that, we will get 4 raised to n equal to 2 into 2 raised to 2n. Sorry, not 2 into 2 raised to 2n, which is equal to 2 into 2 into 2, 2n times. That is 2 cube equal to 2 3 times. The product of 2 3 times. 2 raised to 10, the product of 2 10 times. Here we have 2n. So the product of 2 2n times. So while checking here whether we have the factor of 10, there is possibility of factor of 10 here. 4 raised to n. Here there is no, what are the factors of 10? Prime factorization of 10, that is 2 into 5. Here we have 2, but the term 5 is not present here. So the 4 raised to n to become a factor of 10, we need a 5 here. That 5 is absent here. So whether we will get the last digit 0. So the prime factorization of 4 raised to n have only 2. Okay, no 5s. So the last digit cannot be 0 for any n 4 raised to n, because to get 0 as the last term, we need at least one 5 as prime factor. Here only 2 into 5 gives 10 as the last digit 0. So what we can conclude? We can conclude 4 raised to n is a number which does not end with digit 0.